Welcome to my channel, Statistics for Applied Linguistics. I'm Dr. Marnie Menegra, and in this video, we are going to discuss inferential statistics, and we're going to look at the chi-square. So again, as we've discussed in a previous video, there's a difference between descriptive and inferential statistics. If you remember, descriptive statistics describes the summaries of data using percentages, ratios, or raw numbers. And this data is only true for the participants in your study, whereas inferential statistics allows you to make predictions or inferences about the population based on the sample. So when you use inferential statistics, you can infer that possibly what is happening with your sample could be true for the population that your sample represents. Now, this is the chi-square formula. And a chi-square test is a hypothesis test used to determine whether there's a significant difference between an expected frequency and an observed frequency within certain categories. We can also use this test to determine if two variables are related or independent. So there are two types of chi-square tests. The first is the chi-square goodness of fit. We will discuss this test in a different video, but this test is used to count frequency and will be used to determine whether a population or set of responses fits an unknown distribution. This is used for a qualitative survey, like a Likert scale, to see if the responses are significant or if they're based by chance. The one we're going to look at today is the chi-square test of independence. This test is used to see if there is a relationship between two variables and to see if they're independent or dependent. And this test can be used as a non-parametric test if the sample size is small and the distribution is normal. The first example that I'm going to show with the chi-square test of independence is an example where we're using sets of nominal data with a count. And then you can see how that is done, but I'm later going to go live to show how this can be used as a non-parametric test with a small sample size. So using the chi-square test in place of a parametric test, remember the parametric test, this is where we're going to use a t-test, z-test, ANOVA. We also have Pearson's correlation compared to Spearman's correlation and Kendall's tau, the chi-square, and the Mann-Whitney U. So non-parametric tests, again, we're going to use a non-parametric test when the data is not normally distributed. So this would be for skewed data, or if the data is ordinal or nominal. Okay, so if we have less than 30 participants, we cannot use a parametric test. So this is where we're going to have to decide if we're going to use the chi-square. Now, remember, 30 participants or more in a linguistics study, you can go directly to a parametric test. In other fields, you would need more than 50 participants, but for linguistics, 30 is the magic number. If there are less than 30 participants, then if we have more than 10 participants, but less than 30, you're going to then use the Shapiro-Wilk test. See the video on the Shapiro-Wilk test. If the data is normally distributed, then you use a parametric test, but if the data is not normally distributed, this is where you're going to use the chi-square. So between 10 and 20 or 10 and 30 participants and the data is not normally distributed, we've got the chi-square test. Now, if you have less than 10 participants, you can use a chi-square, or you can use descriptive statistics. But just remember, the results of your chi-square test with such a small sample size are not going to be very reliable. So here's the example of the chi-square test for independence. And this is the example with categories of nominal data. So the categories here, we've got training. There's two types of training. So we're training a cat to dance, and this is an operant conditioning type of study where we're using rewards to model behaviors. So in one category, we're looking at using affection as a reward. And then, did the cat dance? It's either yes or no. So yes or no. And then we've got food as a reward. Did the cat dance? Yes or no? And then we've got the count, which is scale data here. So when we're going to do this, we're actually going into JASP and looking at under frequencies to the contingency table. Unlike t-tests and ANOVAs, there isn't a main category for chi-squares. It's just under frequencies. Go to contingency table. We've got the data coded in nominal and the count and scale. And then what we're comparing is the two types of training to whether or not the cat danced. So it's a 2x2 design. And it's going to give us the output here with a contingency table. And the contingency table is going to give us all the data with a bit of a summary below. Below the contingency table, now what I'm showing you here does not match this exact data set, but this is going to show you what the chi-square output will look like. And this is the chi-square test. Well, how do we interpret this? So the chi-square number, which is the 146.667, tells us how much of a difference exists between the two variables. And this would be the type of reward and the dancing. The degrees of freedom is the number of factors minus 1. And the p-value, p stands for probability. And this is the probability that the variables are related or dependent. And we're going to look at probability and p-value in a different video. So I'm going to go live now, and we'll go directly into JASP, and I'm going to show you how to do a chi-square for independence in place of an ANOVA or a t-test. So I've got JASP open here. I'm going to the main menu. I'm going to open, going to computer, and on my desktop here, I've got chi-square for independent data. Now, because this is for nominal or scale data, or nominal or ordinal data, and everything's showing up in scale because these are tests, we're going to change everything to be ordinal. Otherwise, we're not going to be able to use this test. So we've got 20 participants per category. We've got A1 is the language level with a pre-test, post-test design, and A2 is a different language level. So we've got two different language levels. Let's say they're learning English as a foreign language, and lower beginner, upper beginner, A1 to A2 with a pre-test, post-test design. We're going to frequencies and we're going to go to contingency table. Now, the challenge here is you can only compare two variables at once. So first I'm going to look at the A1 participants with their pre-test and their post-test. And so I've got my contingency table, and here I've got my chi-square table with the value, the degrees of freedom, and the p-value here. With the p-value is greater than 0.05. So for this particular test with the A1 participants, pre-test to post-test, there's no significant difference between the tests. Now let's look at the other participants, the A2 participants, pre-test to post-test. And again, there is no significant difference in the pre-test to post-test for the A2 participants. Now, what we would have to look at then is let's look at the A1 pre to the A2 pre. There's no significant difference at the onset of the study between the two groups. So these two groups are the same at the very beginning of the study. Now we know that the testing didn't work for the A1 participants, but let's look at the A1 post-test to the A2 post-test. And again, there's no significant difference between the two groups at the end of the study. So in this case here, we have to do 4 different chi-squares. Whereas if I had more participants, I could have run this through a repeated measures ANOVA and then also gotten the effect size. And that would give me more information instead of having to do 4 different tests. But Because the sample size is so small, in order to compare them, I have to do 4 tests to compare the 2 different pre-tests, 2 different post-tests, and pre-test to post-test in each group. So this concludes this video on the chi-square of independence. Thank you so much for watching, and I look forward to seeing you in the next video.